Okay, so let's talk about bolus infusions. There are sometimes you're not going to need to do anything really with a bolus infusion, such as this first example. Your client has an order for ampicillin 2 grams and 250 milliliters of normal saline IV stat. This will often come prepared for you, all ready to go, and so you just give the medication as quickly as the patient tolerates it through gravity. We don't have to worry about time. They're getting the whole thing, so there's no calculations involved. Now, later on, we will talk about how to prepare a solution like this, but at this time, for calculating how fast it should run, you don't need to worry about calculating anything. On the second example here, let's talk about heparin. Often when we initiate heparin, what we do is we start the patient on a bolus when they're receiving it via IV. We give them a bolus to get them to a baseline where we want them to be, and then we give them a continuous infusion afterwards. And we're not going to cover the continuous infusion right now, but let's think about what the bolus is. Heparin is usually ordered on a weight-based dosage. So for example, a newly admitted client has an order for 80 units per kilogram heparin bolus. You have a solution available with 25,000 units of heparin and 1,000 milliliters of D5W available. Your client weighs 250 pounds. So the two questions we need to answer are how many units of heparin should the client receive? And then also how many milliliters are we going to give of this solution based on this order? So let's take a look at this together. Let's consider the first question. How many units based on this order are we supposed to give? Again, this is a weight-based dosage. So what does that mean? 80 units per kilogram. That means this client needs 80 units of heparin for every 1 kilogram of weight that they have. So if we know that ratio or that proportion of the order, we need to consider, well, how many units of heparin does the client need then for their entire weight? So first, it's based in kilograms. We have the weight in pounds, so we need to do our conversion there. Every time we want to convert pounds to kilograms, we're dividing by 2.2. And then remember, our rule is to round to the nearest tenth whenever you do a conversion from pounds to kilograms. This is the only time you're going to round in the middle of your problem. We do need to round before we go on to solve anything else in this case. So 250 pounds divided by 2.2 gets us to 113.6 kilograms of weight for this patient. Now I'm going to take that total weight times my order of units per kilogram in order to find out what's the entire amount of medication this patient needs based on their weight. So we take 80 units per kilogram times 113.6 kilograms. It's equal to 9,088 units of heparin. Now, my kilogram label by my 80 units per kilogram is on the bottom of my fraction. So it cancels out when I take it times my patient's total weight in kilograms, and I'm left with just a label of units. Okay, so we figured out how many units we need. 9,088 units of heparin for this specific client. But when I look at my bag of IV fluids and I wonder how much then I'm supposed to give, if my available solution has 25,000 units of heparin in it, and there's 1,000 milliliters of D5W, how in the world do I know how many milliliters 9,088 units is equal to in order to give this bolus? So what I can do is determine the amount of milliliters that I want to give using ratio, formula, or dimensional analysis method like we talked about last term. And so what this is basically is we're just solving a really big dosage problem. If I know that I have my order of 9,088 units of heparin, I can then use my IV solution as my available medication in order to determine how many milliliters I need to be administering. So to solve this as a ratio, what we would do is we would set up our available information on the left-hand side first, and we would say 25,000 units in 1,000 milliliters. And then I would set that equal to what I'm trying to solve for. I need 9,088 units, and so I'm solving for how many milliliters is that equal to. I'm going to cross multiply and divide like normal. So I always multiply the two numbers that are filled in that are across from each other. So in this case, it's 9,088 units times 1,000 milliliters. And then I always divide by the number that's across from my x. In this case, 25,000 units. When I do that, it comes out to 363.5 milliliters. Now remember, this is a dosage, so I'm going to round to the nearest tenth because anytime I have a dosage calculation, and it comes out to be greater than 1. If there's a decimal involved, I'm going to make sure it's rounded off to the 10th. So in this case, I know that if I give 363.5 milliliters of this IV solution, my patient's going to get the 9,088 units of heparin that they need. Let's say I wanted to solve this as a formula. Remember that you always write down your order first, so in this case it's the 9,088 units, and then I always match up that to the available information that has the same label. So in this case, I'm going to write 25,000 units underneath my 9,088 units order. I multiply it by the form that my available comes in. In this case, if I give 1,000 milliliters of this solution, I'm going to give the 25,000 units that's in it. So that's the form that my 25,000 units of heparin comes in, of the form that's available. And then that label should always be matching to what my X label is. I'm solving for milliliters, my form is in milliliters, so we're good to go there. I simply take my 9,088 divided by 25,000 times 1,000. I'm going to come out to the same answer of 363, rounded off to 0.5. So just always remember, whenever you're doing your calculations, don't round in the middle. Always wait till you're rounding at the end. But this is how we would set it up with formula. So now finally, I just want to show you what this looks like in dimensional analysis. And actually, if you choose to do dimensional analysis, you can just solve this problem all at once, unless the question is asking you to break it down into the 2 separate answers. If you're just looking for how many milliliters and that's the only question, you can do this whole problem all at once, all together. So what you're always going to do is you're always going to write down what you're looking for first. In this case, we're looking for X milliliters. All right, so just had to notice that I had an error I had to fix real quick. So if we're looking at dimensional analysis, I see that X milliliters is what I'm solving for. When I write down my available, which is what I needed to fix, I always need to write the label that matches what I'm looking for on the top. And this comes first. So I'm going to write down my available solution since that's what I'm working with. 1,000 milliliters needs to go on the top of my fraction here because that's what matches what I'm solving for. That's the label I want to end up with in the end. So 1,000 milliliters over 25,000 units. Next, I write my order. My original order was 80 units per kilogram. So 80 units over 1 kilogram. And then I also am going to multiply that by my patient's total weight. Now, because I rounded my patient's weight, it's not okay for me to just put 250 pounds in here and then put the conversion 4 pounds to kilograms, because my answer is not going to come out correctly because we round that weight off before we go on to the rest of our problem. So it's only okay for me to plug in kilograms here instead of the weight in pounds and then convert it. So I've got everything that I need here. And how I know that is that I always want my labels to cancel. If you're used to doing dimensional analysis, that sounds really familiar to you. So what's going to happen is my units is going to cancel here and here, and then my kilograms will cancel here and here. What I'm left with is the label of milliliters, and I'll come to the same answer rounded off to 363.5 milliliters. So if I get that amount of this solution, that will be the appropriate amount for this bolus.